So let us see this next question 17. It is related with the spring pendulum. When a body of mass 1 kg is suspended from a certain light spring hanging vertically, its length increases by 5 cm. By suspending 2 kg block to the spring, if the block is pulled through 10 cm and released, the maximum velocity in it in meter per second is the acceleration due to the gravity to take 10 meter per second square. The problem का टाइप मत होता है. Like this. So here we have to find the maximum velocity. So Vmax is equal to omega into A, where A is the amplitude. This is equation A. So you have to find omega and you have to find A. Problem के दो पार्ट हैं. First part. Don't figure card learning. So this is the spring suspended vertically. This is the lower end of the spring. Now, when a block of 1 kg is attached, it extends by x. So this is the block of 1 kg. So M is equal to 1 kg. Extension force is equal to 5 centimeter is equal to 5 into 10 raised to minus 2 meter. This spring has constant K. So this is the equilibrium position O. So in equilibrium position, O of the block, it is equilibrium position, so net force acting is 0. So which are the two forces? One force is MD, acting vertically downward, and other force is Fe, force due to the elasticity. So this is Fg, gravitational force. This is equal to Kx. X is the elongation force. So a restoring force due to elasticity of the spring is equal to gravitational force acting on block M due to gravity of Earth. Therefore, Fe, force due to the elasticity, is equal to Fg. Therefore, Kx is equal to mg. Therefore, force constant K is equal to mg upon x. So substitute the values. M is equal to 1 kilogram multiplied by G 10 gallons निकला है, and this is 5 into 10 raised to minus 2. So this is 2 into 10 raised to 2. So K is equal to 200 Newton per meter. This is the question 1. आपल्याला K माहिती आहे. Second part. Now the same spring is used K, and here the block of 2 kg is suspended and it is pulled down through 10 centimeter. So this distance is called as a amplitude. A is equal to 10 centimeter. When first block M is removed, problem मध्ये हा शब्द दिलेला नाही, and a block of mass capital M is suspended and pulled down by 10 centimeter. Therefore, the block M oscillate with amplitude A is equal to 10 centimeter is equal to 10 into 10 raised to minus 2 meter. This is the amplitude. This is the question second, and it oscillates with amplitude A and with angular frequency omega is equal to under root K upon M. This M can be substituted as M is equal to MO is equal to mass of oscillating particle, oscillating block, oscillating body, and therefore omega is equal to under root K is equal to 200 upon MO. MO is equal to 2 kilogram. MO is equal to 2 kilogram. So this is equal to omega is equal to 100. That is equal to 10. So omega is equal to 10 radian per second. This is the question 3. So we know omega in this equation. We know amplitude. So put 2 and 3 in equation capital A. Therefore, maximum velocity Vmax is equal to omega has value 10 and amplitude has value 10 into 10 raised to minus 2. So that is equal to 1. So maximum velocity is equal to 1 meter per second. Vmax is equal to 1 meter per second. So the correct answer is the B. B is correct. So in this problem we are using two blocks, one small m is equal to 1 kg and other capital M is equal to 2 kg. The role of the two blocks are different. This M is used to find the K because in equilibrium position the spring is extended by x is equal to 5 centimeter due to the load of 1 kg. So this property is used to find the K. Now once we know K, we have to find omega. So omega is given by under root K upon M. So omega is the angular frequency, it is equal to 2 pi n where n is the frequency of oscillation. And therefore this is the mass of the oscillating body. हा जो सेकंड ब्लॉक आपण यूज केलेला आहे तो आपण 10 सेंटीमीटरमधून पुल डाऊन केल्यानंतर रिलीज केला म्हणजे तो या मीन पोझिशनच्या अप अँड डाऊन ऑसिलेट होईल. म्हणजे ऑसिलेट होणारी बॉडी ही आहे एमओ, ज्याची आपल्याला फ्रिक्वेन्सी काढायची. सो एम इज इक्वल टू एमओ इज इक्वल टू मास ऑफ द ऑसिलेटिंग ब्लॉक अँड इट इज इक्वल टू 2 kg. सो के वी हॅव कॅल्क्युलेटेड इन द फर्स्ट पार्ट here. So K is equal to 200 Newton per meter and this mass of the oscillating body is equal to 2 kg. So omega comes to be 10 radian per second. Now the block is further pulled down by 10 centimeter. Therefore it can vibrate with maximum displacement 10 centimeter. Therefore this is called as the amplitude. The amplitude आपल्याला direct ओळखता यायला पाहिजे. It is the distance through which the block is pulled down from the equilibrium position is called as the amplitude. So amplitude is 10 centimeter. Omega is equal to 10 radian per second. By substituting in equation A, we get the maximum velocity is equal to 1 meter per second like this. Next question number 18. A spring constant K is cut into the 4 equal parts and 2 parts are connected in parallel. What is the effective spring constant? 4K, 16K, 8K and 6K. So it is a very important problem because we have to use the series and parallel connection. So the simple rule, I will prove it afterward. The simple rule is this. Force constant P is equivalent to capacity of a conductor. Capacity of a conductor or condenser. So K is equivalent to C. For 4 condensers in series, 1 upon Cs is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3 plus 1 upon C4 is equal to, if C1 is equal to C2 is equal to C3 is equal to C4 is equal to C, then 1 upon Cs is equal to 4 by C and therefore Cs is equal to C by 4. Effective capacity is equal to. Similarly, I will show this figure. A spring of constant K is divided into 4 equal parts. Then this is the original spring. And now it is divided into the 4 parts. This is the first spring, this is the second spring, this is the third spring, and this is the fourth spring. So this is K1, this is K2, this is K3, this is K4, this is K is equal to series combination. Therefore 1 upon Ks is equal to 1 upon K1 plus 1 upon K2 plus 1 upon K3 plus 1 upon K4. Therefore 1 upon Ks is equal to 4 upon K1. Therefore Ks is equal to 1 upon K is equal to 4 upon K1. Therefore K is equal to K1 by 4, or K1 is equal to 4 times K. K1 is equal to spring constant of each part. Spring constant of each part. Each part out of 4 parts. So K1 is equal to 4 times K. This is equation 1. No. This is the first part of constant K1. This is the second part of constant K2. They are connected in parallel. Like this. When two springs of constant K1 and K2 are connected in parallel. Then effective value of force constant Kp is given by Cp is equal to C1 plus C2. Similarly Kp is equal to K1 plus K2, but K1 is equal to K2. Therefore Kp is equal to K1 plus K1, that is equal to 2 times K1. This is equation second. या कॉम्बिनेशनची फोर्स कॉन्स्टंटची व्हॅल्यू Kp आहे, त्याच्यामध्ये K1 ची व्हॅल्यू ही सबस्टिट्यूट करा. मग पुट 1 into therefore Kp is equal to 2 times K1 की value ही 4 times K, so that is equal to 8 times K. So the effective force constant is equal to 8 times the force constant of the whole spring. K is equal to spring constant of the whole spring before cutting. Spring constant of the whole spring before dividing into 4 equal parts. So Kp is equal to 8 times K, and therefore the correct choice is C. Therefore C is correct. C is correct. Now we have used this relation 1 upon Cs is equal to 1 upon K1 plus 1 upon K2 etc. 1 upon Ks is equal to 1 upon K1 plus 1 upon K2. How? That can be proved easily. So let us give the proof of that equation. Ks is equal to 1 upon K1 plus 1 upon K2 plus 1 upon K3. How? So that when a spring of constant K is divided into n equal parts, then the force constant of each part is given by n times K. Answer. So we are using this figure. This is figure 1. Consider n is equal to 4 as shown in figure 1 and figure 2. As shown in figure 1 and 2. But the property of elasticity, force constant K is equal to YA, force constant K is equal to Y upon L. L is equal to length of the spring, length of the original spring. So L is equal to L1 plus L2 plus L3 plus L4. This is L. This is L1. This is L2. This is L3. This is L4. Now L is equal to Y upon K. Then Y into A upon K is equal to Y into A upon L1 K1 plus Y upon K2 plus Y upon K3 plus Y upon K4. Therefore, y cancel. So 1 upon K is equal to 1 upon K1 plus 1 upon K2 plus 1 upon K3 plus 1 upon K4. So K is equal to Ks is equal to spring constant of series arrangement of force spring. If K1 is equal to K2 is equal to K3 is equal to K4, then 1 upon Ks is equal to 1 upon K1 plus 1 upon K1 plus 1 upon K1 plus 1 upon K1 that is equal to 4 upon K1. Therefore 1 upon K is equal to 4 upon K1. For n parts, K1 spring constant of each part is equal to n times K. So K1 is equal to spring constant of each part out of n equal parts, and K is a spring constant of the original spring. Before cutting. So K1 is equal to 8 times K. Force constant of each part is equal to n multiplied by K. म्हणजे स्प्रिंग डिवाइड केल्याने फोर्स कॉन्स्टंट वाढतो, इलास्टिसिटी प्रॉपर्टी स्ट्रॉंग होतात. Like this. So this proof can be used. So there are number of problems using series and parallel arrangement of the spring. So this is the simple result. कंडेन्सरचे जे सिरीज पॅरललचे फॉर्म्युले आहेत तेच आपल्याला स्प्रिंगसाठी यूज करता येतात. सो 1/CS इज इक्वल टू फॉर 4 कंडेन्सर 1/C1 प्लस 1/C2 प्लस 1/C3 प्लस 1/C4. Similarly, this is the equation for the this spring constant of the series arrangement of the 4 spring. So when 4 spring of constant K1, K2, K3, K4 are connected in series, then they will have effective force constant given by this relation. Similarly, for parallel arrangement of condenser, Cp is equal to C1 plus C2. So if the two strings are connected in parallel, then Kp is equal to K1 plus K2. So this is the formula for the parallel arrangement. This is the formula for the series arrangement. So for series arrangement, we have proved this equation. If the spring of constant K is divided into the n equal part, then the force constant of each part is given by n multiplied by K. आपण 4 स्प्रिंगसाठी इथे प्रॉब्लेम यूज केला होता, तो n पार्टसाठी यूज केला तर आपल्याला रिलेशन याप्रमाणे प्रूव्ह करता येऊ शकतं. नेक्स्ट problem number 19. A pendulum of length L meter is released from theta is equal to 60 degree. The rate of change of speed of the bob at 30 degree is given. G is equal to this one. The unit बघा मीटर पर सेकंड स्क्वेअर मध्ये आपल्याला ॲक्सेलरेशनची व्हॅल्यू काढायची. So the acceleration is given like this. Rate of change of speed is equal to acceleration of the bob of a pendulum. Then symbolically you can use rate of change of speed dv by dt is equal to A is equal to minus omega square x. This is the equation capital A, where x is equal to displacement of the bob from mean position like this. So this is the equilibrium position, this is the deflected position. So this distance is x, this is L, this is also L, this is theta. So OAB. In triangle AOAB, theta is equal to length of the arc upon radius. Therefore, theta is equal to x by L. Therefore, x is equal to L into theta. So this is the equation 1. म्हणजे x माहिती आहे आपल्याला. Now, for simple pendulum, period capital T is equal to 2 pi multiplied by under root L by D. Therefore, root L by D is equal to 2 pi upon capital T is equal to omega squaring. So G by L is equal to omega square. This is equation 2. So we know omega. Equation 2. We know x. So put 1 and 2 in equation capital A. Therefore, dV by dt, rate of change of speed is equal to omega square is equal to G into L into theta. So this is equal to G into theta. G into theta. This is equation B. In magnitude. Upon minus n cut केले. So acceleration A is equal to dV by dt is equal to G into theta. नवीन फॉर्म्युला आपल्याला माहिती आहे. So substitute the values there. Therefore, dV by dt is equal to G into theta is equal to G is equal to 10 and theta is equal to 5 by 6 radian. Radian मध्ये value आपल्याला घ्यावी लागेल. So this is equal to 5 by 3 multiplied by 3.14. So this is approximately 5 point something. So this is 6.25. Multiplied amplitude is given. G is equal to 10 and theta is equal to 30 degrees. So 30 degrees is equal to 5 by 6. So this is equal to, sorry, it is nearly 5 meters per second. So rate of change of speed is equal to this much. हा फॉर्म्युला जरा नवीन आहे, लक्षात ठेवा. G into theta. So the correct answer is C. C is correct. Like this. So remember the procedure. We have to find the rate of change of speed, means we have to find dV by dt, and it is nothing but acceleration. So in SHM, acceleration is given by minus omega square x, where x is the displacement of the bob from the mean position, this is the x, and omega is the angular velocity. It is given by 2 pi upon capital T. So that relation we have used here. Omega is equal to 2 pi upon capital T, and period of the simple pendulum is given by 2 pi multiplied by under root L upon G, where L is the length of the pendulum. So omega square comes to be G by L. So we know omega square, we know x. The x साठी आपण ही सर्कलची प्रॉपर्टी यूज केलेली आहे. लेंथ ऑफ द आर्क AB upon radius L is equal to angle theta. So theta is equal to x upon L, therefore x is equal to L into theta. So if we know the theta, more the value of theta, more will be the length of the arc, like this. So in our problem, what is the important point? The two angles are given. One angle is given 60 degree. So initially the bob is taken from OA equilibrium position to 60 degree and then it is released. So when it is released from this positive extreme position 60 degree, then it will pass through this B position where theta is equal to 30 degree. So when it passes through the point B, at extreme position its velocity will be 0. Acceleration will be maximum. So when it passes through the point B, then the rate of change of velocity or acceleration at point B is given by this value. So why two angles are given? The reason is this. So next question is 20. It is similar to question number 17. Only in question number 17 there is a case of extension. In this case it is a case of compression. I will read the problem. A body of mass 2 kg hang from a spring and oscillate with a period of 0.5 seconds. On a removal of the body, the spring is shortened by. So in that case, we have applied the load and therefore the spring extends. In this case, the spring is shortened. So theory is remaining same. So arrangement is the length. This is the spring of constant K. So the block of mass M is suspended here. It is oscillating. Now when it is removed, then the spring contracts by X. So you have to find X. X is equal to question mark. Let X is equal to contraction in the spring when block M is removed. So when block M is attached to spring, then in equilibrium position O, same formula we are using. In equilibrium position O, the force due to elasticity of the spring is equal to gravitational force acting on block M due to gravity of Earth. Therefore, Fe, force due to the elasticity, is equal to Fg, G for gravitational force. So this is equal to Kx is equal to M into G. Therefore, X is equal to M G upon K. This is the equation 1. You have to find K, where K is equal to M omega square is equal to force constant of the spring. Therefore, X is equal to M into G upon M omega square. So this is equal to G upon omega square. This is equal to G upon 2 pi upon capital T whole bracket square. Therefore, compression X, compression in the spring, X is equal to G gt square upon 4 pi square. This is the problem. And now we are going to substitute the value. So x is equal to g is equal to 10, t is equal to 1/2 second upon 4 multiplied by 9.87. So this 10 and 9.87 nearly cancel. So this is equal to 1/4 multiplied by 1/4, that is equal to 1/16 meter. So x is equal to 100/16 centimeter. So that is equal to 6.25 centimeter. So the spring will compress by this much centimeter. Spring is shortened or compressed by x is equal to 6.25 सेंटीमीटर. आपण इलॉंगेशन करतो किंवा इलॉंगेशन दिलं असेल तर आपण के करतो. सो द करेक्ट चॉइस इज सी. इथे पण 5 चॉइसेस दिलेले आहेत आपल्याला, ए बी सी डी ई. सो द करेक्ट चॉइस इज दिस 6.25. 6.3 पण आपल्याला दिलेलं आहे. आपण जरी ॲक्युरेट कॅल्क्युलेशन केले तरी हा जरी 9.87 10 ॲक्युरेट व्हॅल्यू घेतला तरी पण तो 6.3 ने होईल. सो द करेक्ट चॉइस इज गिवन दिस. So the procedure is now exactly opposite. When the spring is unloaded, its lower end is here. When a block of mass m is attached due to the gravitational force acting on it, the spring will extend by x. Now if the block is removed, the spring will return to the original position due to the elasticity. It is a restoring force which is responsible to bring the spring to its original position, and therefore when the block is removed, when the block M is removed, the spring will shorten by a length x, and that we have to find this x. X is equal to question mark, and it is calculated like this. So this force due to the elasticity in equilibrium position is equal to gravitational force acting on the block. So Fe and Mg, they are equal in magnitude and opposite in direction like this. So we can show the forces like this. This is the Fg is equal to mass multiplied by gravitational acceleration, and this is the Fe, the force due to the elasticity of the spring. It is also called as the restoring force in magnitude. Actually it has minus sign like this. So Fe and this Mg, they balance each other, and therefore this is called as the equilibrium position. So the net force acting on the block is this. So in equilibrium position, the extension produced in the spring is x. Now if the load is removed, the spring will shorten by x. So formula remains the same, whether it is a elongation or whether it is a shortening of the length of the spring like this. Okay, we will stop here.